When a fluid is enclosed in a container, its particles collide with each other, but also with the sides of the container. The amount of collisions between the particles and the size of the container determines the pressure exerted by the fluid. The more collisions, the higher the pressure. When this enclosed fluid is compressed with a plunger, it might look like nothing is happening, but that is far from the truth. Once a force is applied to the top of a fluid, the pressure increases at the point of contact and throughout the whole fluid. This is Pascal's law. It states that pressure applied to an enclosed fluid is transmitted without a change in magnitude to every part of the fluid and to the walls of the container. This principle can be used in technological systems when a force needs to be transmitted or amplified. Pneumatic systems use compressible fluids, and hydraulic systems use incompressible fluids. Here, a tube filled with water is closed at both ends by two identical pistons. The first piston is used to apply a force on the fluid. The pressure increases here as well as throughout the fluid. Therefore, it exerts a greater pressure on the sides of the container. Also, the second piston receives a force of the same intensity as that applied directly to the first piston. With this system, it's possible to transmit a force while conserving its intensity. But what happens if the size of the second piston is modified? Let's take a look at a piston that is 3 times larger. By applying a force to a small piston, the pressure increases throughout the fluid. The pressure exerted by the water on the second piston is the same, but the sides of the large piston experiences 3 times more particle collisions. As a result, the force applied to it is tripled. The effect can be demonstrated using the formula P is equal to F over A, where P is the pressure of the fluid in pascals. F is the force applied to the piston in newtons, and A is the area of the piston in meters squared. Here's an example with real values. Say an initial force is applied, F1 of 10 newtons to a small piston. The area of the small piston, A1, measures 1 meter squared, and the area of the large piston, A2, is 3 meters squared. What is the force F2 applied by the fluid to the large piston? The pressure applied to each piston is expressed by the following formula. P equals F divided by A. According to Pascal's law, we know that the pressure is the same throughout the fluid, so P1 and P2 have the same value. In other words, we can say F1 divided by A1 is equal to F2 divided by A2. Let's isolate F2 and replace the variables with the known values. Based on the calculations, F2 equals 30 newtons. This means that by applying an initial force of only 10 newtons, a 30 newton force is generated. Pascal's principle is the foundation of many technological systems. A hydraulic lift is a system that lifts heavy loads, like a car, for example. In this system, there is a small piston, a large piston, and an incompressible fluid, usually oil. A force is applied to the small piston, which increases the pressure throughout the fluid, including the large piston. Because of its large surface, the large piston amplifies the initial force, which enables the lifting of the car. In summary, a fluid always applies pressure to the sides of its container. When the pressure changes at a specific place in the fluid, it will change throughout the fluid. This property is used in different types of mechanical systems to transmit and amplify forces.